Good morning, ladies and gentlemen. My name is Che-Wei Hsu from TSEC in Taiwan. Thank you all for being here. I'm very glad to have this opportunity to share my thoughts about carbon reduction solution with you. As we know, renewable energy should be one of the best ways to solve this problem, especially solar energy. So, I will be talk about our experience on future challenge and opportunities of PV module. I will divide my presentation into 5 parts. I'm going to start with brief introduce TSEC. Then I will talk about the current challenges and opportunities. The third and fourth part will describe how TSEC technology and advantages was integrated to our innovation product. And finally, what any challenges we have there to work it out. About TSEC, it means Taiwan Solar Energy Corporation. Until now, our team has been few decades experience in semiconductor materials, optoelectronics, manufacturing, and so on. Therefore, our business involvement are including solar cell, module, and the EPC system, as shown in top. Today, the Hsinchu cell plant and the Pingtung module plant of TSEC are both process maximum throughput 1.5 gigawatts. Now, we have the only one big module size and the largest capacity in Taiwan. Back to this topic, we saw that there are 3 main aspects to future opportunities: climate change, reduce carbon emission, and the PV safety. As we know, climate change is an old issue which causes the weather or environment getting worse, such as heat waves, Arctic melting ice, typhoon, and the tsunami. And last month, I noticed Vancouver post a study that talking about 96% humans have feared global warming. So this is why we are here trying to figure out the solution. Now, how to reduce carbon emission has become an important topic. So most countries have promoted many PV systems by policies and the grants over the past decade. But the reduction in carbon emission are still insufficient. It is necessary to face the insufficient installation size issue if we must continue to increase the PV system. This is also another chance. Lastly, we believe that the safety of solar energy is also a very important issue due to number of PV systems increase. In addition to solve people's thoughts about pollution or taxes of PV modules, the loss of life and the property caused by solar fire has often been here in recent years, which is also the motivation for us to improve product safety. Based on mentioned issue, we could summarize 3 potential challenges. First of all, in harsh environment issues, Taiwan is surrounded by sea and close to the equator, which makes belong to isolated climate of subtropical. So Taiwan faces more severe challenge than other countries because of high temperature, humidity, drought, great correlation, and the typhoon. This is why we are focused on developing the stronger frame and select the right material to fight this environment as shown in bottom left. These characteristics are including anti-wind, anti-corrosion, anti-UV, strain edge sign. Secondly, for installation fear reduction issue, in general, there are 2 directions able to do. One is using higher power and efficient module on limit field. And another is find other alternative fields, such as ponds, lakes, ocean, or other spatial sites. Based on these statements, In addition to continuous development of large size, high power, and high efficiency modules, it is also necessary to strengthen waterproof and anti-corrosion properties for using floating, acrobatic, and so on. At least, it's about PV safety issue. People are always concerned about leakage of substances from module to the water or land. It will endanger human or electrical health if it does happen. Another important issue is about fire safety. As we know, there are more and more PV fires in recent years. In addition to the property roads, how to protect the firefighters safe also need to concern. According to Protective Environment Classification of ISO 9223, most of Taiwan's environment is belong to C4 to CX. Currently, we have successful passed some tests under different severe conditions, such as Test 7, Test 8, and the CAT. It is worth to talk about that we also passed Test 8 plus PID-D testing. Based on laboratory's instructions, our module have been proved to withstand the ocean climate for 40 years. Today, more and more PV systems have been installed in farm, beachfront, or lake as shown in photo. In order to prove our module is safety, we intentionally broken modules and immersed in water for a few days, then taking out the water and testing it to confirm that there were any relative toxic substance leaking out. The test report is shown in bottom left. It can guarantee our products are safe. Here, I will show our related design experience. The first part is about traditional layout design of cell and the module. Of course, we also have some customization experience in some fields, such as aerospace, automotive, and so on. The second part is about performance improvement as shown in right. The strand edge design solved the problem of rainbow pattern and the hotspot, thereby increasing the power, while the structural design increasing the wind resistance to protect the module. This design helps enable us to successfully pass the IEC and the PVEL test. Today, our module could be withstanding 7,100 pound over 5,400 pound by ML test and the severe typhoon of 17 level by wind tunnel test respectively. In addition, we are also continuously improving our manufacturing technologies, such as non-destructive cutting, high-density interconnection, and so on. Now, we have integrated all the features and the technologies into innovative modules called Skyhawk. This type will be suitable for use in Iceland climate or harsh environment. Now, M10 module is our current main product. It is included for different size and power as shown in below table. The maximum power is about 540 watts. Here, all of our reliability tests were summarized for both M6 and the M10 type. You can check this report on our website if you are interested. By the way, we also have some demonstration fields to simulate the performance of different application fields, which is instructed by our EPC team. And this slide shows several of our important projects in Taiwan in recent years. Finally, about PV future, there might be two kinds of challenges, China issue and the technology development for future application. As we know, Most of PV industrial materials come from China. So, how to reduce relay on China is an important issue for all of us. In fact, we are trying to solve in two aspects: technologies and materials. Firstly, because of Taiwan's high environment pose that we have chance to develop our technology and became our advantage. Moreover, anti-wind and anti-corrosion properties of TSEC module are both top leaders in the world. This technical difference can also help us to distinguish TSEC and the China module's value or quality. The second part is about material problem. Although it is still impossible to get out of control the China's materials dependence in the short time, but we continue to search and evaluate all possible second sources, especially in local solutions. Then, in order to reduce several complex issues, such as shipping, quality, policy, and so on, we also try to do collaboration development with some suppliers. However, costs always trouble us. This is a reality problem as most of solutions are not competitive price. Today, solar energy is currently key project of Taiwan's energy policy. So, if we want to break through the international competition in the future, we hope the must have some policy assistance to develop best research with competitive price. This should be very helpful for the Taiwan's PV development. At last, I will briefly share our point of view in the PV future and what can we do. Of course, in addition to continue to exchange our own advantage, we are interested in following three topics: recycling, energy storage with PV system, and PV fire safety. When it comes to module recycling, the TSEC role is currently focused on evaluation suitable recyclable materials with original performance. We also try to carry out some collaboration development plans for developing some new material. On the other hand, the big problem of PV system is no power in the night. In addition to grid-connected power, energy storage is another best option at present. Our future goal is going to study how to integrate both systems to achieve best efficiency. Finally, PV fires are getting more attention in recent years. The main reason is that the PV module will continue to generate electricity when a fire occurs, which causes firefighters at a risk of disaster relief. Now, we have started to survey any possible solution. For example, rapid shutdown system called RSD. Moreover, how to reduce the risk of firefighter is also one of the important topics in the future. Lastly, I appreciate the time you took to listen to my sharing. Thank you so much. By the way, the bottom of this slide has my email. If you have any question or suggestion, please feel free to contact me. Wish you have a nice day. Thanks again.